Alright, going to go ahead and simulate installing the NSX environment. You can already tell from here that NSX is installed already. We have all of our different pieces and parts already on here. So this NSX-T1 and T2 are our controllers, and we have our edges here. But if we were to start from the very beginning, we would go ahead and say deploy the OVF template. And go ahead and find the files, which would be right here. We can go ahead and select that. It'll validate the file. Go ahead and click next. It's going to go ahead and ask us where we want it, what we want to name it, give it the compute resources. Go over a bunch of different details. I believe it's going to go ahead and ask us some of the standard questions like what do you want the IP address to be, where's the DNS server, where's the time server. So it'll go ahead and start asking all of the in-depth questions. There we go. This piece here. So in general, just go ahead and go with the medium. Tell where we want it, put it on the vSAN, good to go there. What network we want, IP allocation, we're going to manually set that. Alright, this is where we would go ahead and have all the different IP addresses, put in the host name, what role it is, the global manager site, gateway, DNS server, yeah, so all of our standard stuff in here. This is the internal use only. We don't set anything down below here. So not a bad idea to set up SSH, allow root login, give it the NTP server so that it knows who was the last to write where. So your standard settings, and then after that it'll go ahead and build it out. When it rolls it out, you end up with this nice NSX-T. So once you have your NSX-T open, go ahead and it'll open you to this page. It'll try to walk you through some stuff. So down in here, it'll go ahead and do a get started and what are your next steps. So inside of that, what we're going to get is the appliances. What we would have just built through that entire segment there would have been one of these guys, and then it'll ask you to add two more. In an enterprise environment, you will definitely want two more. So you go ahead and you start building them out. I believe you'll run through the same IP address settings, all of that good stuff. So the reason why you want three is that it has these functions that need to be running. So if any one of these were to fail, then what it'll do is it'll fail over to another member of the cluster. The way that it fails over is you will be able to set a virtual IP. So for your 3-node cluster for management, you're going to have 4 IP addresses. You'll have your virtual IP, and that will end up looking at which is available up and ready between these three. And these three will communicate with each other. They all have to be on the same VLAN, all in the same network segment. They'll communicate with each other, make sure that all settings have been set across the cluster, and that way if you lose one, you still have two that all have good settings. Now, this is the piece that if you lose it, you're not going to be able to recover it easily. When this guy fails, it fails. It does not come back. So, down here, you can set up a backup and restore. Go ahead and set it up. I've got it as an SFTP going over to another server, and the directory path of that server. It tells me when the backups have been done. Believe we have a schedule where it'll tell you you can roll, the last, 4 backups, keep one for a week or two. You can have it so that you keep a weekly for 6 months, something like that. So it'll allow you to get a little bit more granular and get rid of. Where I believe it might just be how many do you keep total. Now, if you were to ask a high-speed group, people that are actually building out NSX for cloud for a lot of clients, they do hourly backups. So recovering to that hourly backup, that's going to be pretty critical. The other piece of this is that if you were to go ahead and roll out your appliances, if you lose all of your appliances and you need to get started from scratch with your appliances, then you're going to want to make sure that you're on the same version. So what I went with the installation over on the vCenter server was installing 3.0.0. So if we installed 3.0.0 and then tried to recover from backup, it does not patch it. So what you'll want is the OVA for the most recent version to recover your backup to. So for that, in your upgrade folder, you'll be able to see any bundles. It looks like you'd want to be directly logged in there. Any bundles, you'll be able to identify what the most current version is, but you'll want to have that inside of your repository with OVAs and ISOs, and clear out the old. So when you go ahead and you do your transfer over to new versions from 3.0.0 to 3.0.1, eventually 3.0.2, you'll want to go ahead and make sure that you have a good running configuration and get rid of the old OVA. So once you have your cluster up and running and it's listed as stable, then you're going to need to add your compute manager. Compute manager is your vCenter server. If you're on version 7, so what we end up doing here is we end up adding a compute manager, but in version 7 you can trust the version 7, and that way you can go ahead and do a few back and forth API configuration calls that will allow changes in the vCenter to be reflected over in NSX, and changes in NSX to be reflected over in the vCenter without additional authentication. So that's going to be incredibly important as PaaS environments become more popular. If we were to add a compute manager, you give it a name, you give it a type, FQDN, username, password. You'll go ahead and put in the username, password, and then it'll pull the thumbprint from it, and you'll want to trust the thumbprint. So once that's done, you'll be able to see your clusters. So when we look at our host transport nodes, usually it defaults with just standalone hosts. You'll drop down to find your compute manager. You'll be able to see your clusters, see what their status is. So these guys are already up and configured. Before configuration, if you were building this from scratch, you would just see this, wouldn't be configured, anything like that. To begin configuration, we're going to go into networking. We're going to create IP address pools. So our IP address pools, we have our overlay IP pool, our VLAN uplinks, VTEP IP pool. So our VTEP IP pool, I believe this would be inside of the subnets. So I've got a 10.10.10. I believe this is not in use anywhere. It's just a IP pool that was placed in there. Inside of this guy, we've got 10.10.6. 10.10, from 20 to 40, so we've got 20 IP addresses in here. So that IP pool has 20 IP addresses for our VLAN uplinks. I actually should rename that to VXLAN uplinks. And we have our overlay IP pool, and this one has 10.10.2, 65 to 80, so we've got 15. So let's go ahead and go over what this means. So in order for us to have the north and southbound routing and something that we can program on our east-west routing, we need to have a, go ahead and go over here to show you, an edge transport node. So the edge transport node is what this server, the controller server, communicates with. So we drop configurations, we're creating it here in this web GUI, And what we create here gets pushed over to these edge transport nodes. So the edge transport nodes need to communicate with each other. I have 3 here due to the fact that I needed to upgrade. I believe I set these at medium, and I actually needed large for the use case of an experiment I was running. They should generally just be large as a starting point. So you have large, extra large, and then bare metal. Um, Large is definitely the starting point for anybody that's going to be using in-house NSX. Uh, if you were controlling something in the cloud, you'd use small, and if you were doing a small proof of concept, you use medium. For standard operation, we're good here. Now, in order for these guys to talk to each other, they're going to create a tunnel. Now, the type of tunnel is Generic Network Virtualization Encapsulation, or Geneve. So the Geneve encapsulation is how we're going to head and communicate back and forth with each other. The tunnels on these guys, NSX Edge 2 and 3, you can see they're on that 10.10.2 subnet. Now, realistically, to ensure that we don't have a confusion between the nodes when the network is talking, because it is encapsulated, for every NSX Edge cluster, and that cluster consists of those edge transport nodes. So those edge transport nodes, that is the number of IP addresses that we need inside of that IP pool. So I overshot like crazy creating that IP pool with, I believe, 15 IP addresses. We only need enough for the edge transport nodes. Now those edge transport nodes, once again, because it's encapsulated, are going to be on a different VLAN than the transport nodes that are on the hosts. And I'll get into that in a minute. But because you have 2 different areas that are encapsulating traffic, you're going to need 2 VLANs. So creating those IP pools, you can do blocks or ranges. You'll set those before you start building out your edge transport nodes. So when you go to take a look at this, got these guys all communicating with each other. This is all fine and dandy, but we're not to the point where we would set this up yet. We'd set up our IP pools first, and we'll want to set up our transport zones. So our transport zones, this is where the overlays are going to ride. So the VLAN, this should be VXLAN, and the reason why I label that VXLAN is that inside of VMware, if we were to look at the VM kernel adapters that are assigned when you install NSX, they still can call that TCP/IP stack VXLAN. So we are not using VXLAN encapsulation, we are using Geneve encapsulation, but the easiest way to identify, hey, where is this encapsulation supposed to run? What is this named? VXLAN. So VXLAN there, overlay there. We now have, and I mean you can use the defaults that are in there as well. This is just so that you can go ahead and get in, take a look, create your own. We can go ahead and edit it. There's not really anything in there other than overlay and VLAN. I believe in the VLAN, yeah, there's no real teaming policy or anything you need to do there. Another fun thing about this is that because of the need to recreate pieces and parts, this is a very profile and policy driven environment. So once you create your overlay and your VLAN that you want to have attached to your environment, we'll go ahead and start building out our profiles. So for your hosts, you're going to have a transport node profile. So you have a transport node profile here. We can go ahead, edit this guy. Transport node profile. We're going to use a VDS. We're allowed to use VDS because we're on VMware 7. Otherwise, you'd have to use an NVDS. It's standard mode, so everybody can use it. Our transport zone is going to be the overlay transport zone. we've created an uplink profile. Now you can create the new uplink profile right here. The uplink profile that we're using looks like we've got 2 uplinks, and we're using the VLAN uplinks. So that's the IP pool. So the uplink profile, we can see in here we have a transport VLAN of 6, so we are using VLAN 6 for that. That's that 10.10.6. Default teaming, so uplink 1, uplink 2, we have got an active and a standby, which is why inside of the transport node profile, when we apply the uplink profile, we have to assign the active and standby. Once that piece is done, once you've created those 2 profiles, we can go ahead and get back into the hosts. Click right there, tell it to configure NSX. We tell it what profile and apply it. And once that's applied, good to go. If we wanted to change something around, we can go ahead and edit that profile from inside. There's no reason to do that right now. We're pretty much good to go. For the edge transport nodes, we're going to go ahead and add an edge. So give it a name, fully qualified domain name. This is where I was talking about you'd want a large. The default should be large, if not extra large. Once you create these, though, if you're worried about resource utilization, you can go ahead and tell it, hey, don't reserve anything for me. Give me a normal reservation here. Once you get through that, you'll have credentials where you give it an admin and a root login. You configure, how exactly it's going to be laid out. Let's see what we got here. We can do test and test.fullyqualifieddomainname.com. Give it credentials, so it is going to be a security compliant credential, so you'll have to give it, nice big long credential. You'll always want to allow SSH login when you're building these out so that you can troubleshoot. Same deal here. You're going to go ahead and give it the secure login. Allow the login. You can tell it where you're going to put it. You can tell it host, data store, any of that good stuff. So we can go ahead and put it right there. IP assignment. So this is our management default gateway. What interface we're going to use. So what port group on the distributed switch we're going to use. Domain names, search domain names, DNS and NTP. Of course, all of these things, they need to be able to find each other, see each other, and they should have the same time. Now, I'm not going to hit next because the configure NSX is what happens when we edit right here. So this is where you can go ahead and add switches. You're going to have a name. Switch name is VLAN with the VLAN transport zone. We're going to go ahead and give it a single NIC uplink profile, so we only have one NIC of this VM going up into the NSX uplink. And then we're going to have our transport node overlay. So we're only going to have a single NIC here. We can have multiple NICs here for our overlay. If we believe that our overlay is going to be incredibly chatty, more communication between the tier 0 and configuration of tier 1 than there will be between the tier 1 to tier 1 distributed. So between the hosts here, between your edge transport nodes here. And so we just go ahead and, give it its IP. Give it its IP pool. So as we saw, that's the 10.10.2, and that has a 10.10.2 VLAN tag on it, so we don't have to worry about VLAN tag there. All right, so Once we do that, it'll build it out. You would more than likely want to have 2 or 4 of these. So once these guys are built, we're able to go ahead and start establishing communication, make sure that we can talk to them. So one of the ways that I've found is really, really nice to do that is from inside the system. We can go ahead and verify that we can ping with a size greater than standard MTU, so greater than 1500, over to both VLANs. Make sure that you can get above 1500. So the default over here for their MTU size is 1600. You can manually set it to 9000. 1600 is usually ideal. Most VMs communicate at 1500. Most systems communicate at 1500. So 1600 just not that big of a stretch. The secret to this, though, to be able to ping at a size over 1500 is you have to set your network interface to greater than 1500. So MTU is great big jumbo frame here. Now this is all to configure your overlay. So another fun part about this is your underlay, your physical infrastructure underneath of this needs to support jumbo frames. So if we were to look directly at our distributed switch, look at the configuration, we'll see that we have jumbo frames there. If we were to look at the underlying physical switch, we have jumbo frames assigned to the VLANs that are required and jumbo frames on the interfaces going out to the hosts. So we would have a full path of greater than 1500 MTU all the way through, and make sure that we can route it on layer 3. So the piece that people are going to get stuck on, absolutely 100%, because it didn't make sense to me, and I don't expect it to make sense to very many people, is that these nodes communicate with each other. And that's why they're on their own VLAN. That's why they have encapsulated traffic on their own VLAN. These guys also have encapsulated traffic, and they communicate on their own VLAN. The edge transport nodes also have a network interface to get back to the host transport nodes, so back to your VM hosts. That's why they have assigned to them 2 different transport nodes. They have their tier 0 router, which is your north-south, and that is a service router and distributed router, and then the tier 1 service router and a copy of the tier 1 distributed router. So your tier 1 is your east-west. So they have all of that configuration residing on them. So they make sure that they have dispersed that information where it's required across these transport nodes. Once those transport nodes are all configured and communicating with each other, they are sending encapsulated traffic back and forth to each other to make sure they're synchronized, and anything that needs to get from one of the tier 1 to the tier 0 or from the tier 0 out of the egress point can go through across these. The host transport nodes are going to be receiving, get from the egress, ingress router point. If they have something that is at an exact 1500 MTU, once it becomes encapsulated, it'll go to 1600, go through the edge transport node down into the host transport nodes. So the hosts will need to be able to accept from the 10.10.6 edge transport node will be, it'll hit the router, get into the encapsulation on 10.10.2, disperse itself across the edges. It's going to go ahead and communicate from those edges. They also have the connection to 10.10.6 down to the correct hosts that have the 10.10.6. So, how do they know to do that? Is that they establish their tunnels. And their tunnel endpoints, if you have a VM running, it'll have a tunnel to it. A VM running that is connected over to the NSX segments. Then it'll have connectivity. It'll be able to identify what system is running there, and it'll be able to go ahead and set up its tunnels so it can communicate all the way down to that particular VM or service that's residing in on the host transport node. So by far that is the most difficult thing to wrap your mind around, is transport zone here for these guys to communicate, transport zone here for these guys to communicate. They get the extra little transport zone connection to go to the host though. So, you know, their own VLAN and a VLAN for these guys. So good stuff. As long as they're able to route back and forth to each other, they're able to communicate. You need to be able to have an MTU of minimum 1600 go from this VLAN over to this VLAN. So if you do not have that jumbo frame MTU and you start sending packets that are above 1500 MTU across, you'll see this turn red and go to down very quickly. We can also take a look at these guys and see the software defined switch inside of it. Because we have an active and standby, when we went ahead and did our profile for the host transport node, we went ahead and told it, hey, we want to make sure that you have a physical uplink that's active and one that's standby. So this goes into your port channeling. If you set up port channels so that you can go ahead and get immediate failover on your VMware hosts, you could set this up as active. In general, there's probably not enough traffic and enough or a high enough failover requirement for most use cases to go active. And even when you go active, it could still not be fast enough in failover to meet your requirements. So active standby is absolutely fine, not a big deal. All right, so that covers the install. I guess for the edge transport nodes, that last piece would be you need to put them in a cluster, because when you start assigning how you're going to connect, you're going to be assigning to a cluster. So that is the installation, and I will create another video about some basic troubleshooting and understanding some of the deeper details involved in configuration.